In this video, I'm planning to explain the logarithmic equations of the form fx logarithm base fx gx is equal to logarithm base fx hx. Here, the conditions are fx should be greater than 0, fx it shouldn't be equal to 0, and gx must be greater than 0, hx must be greater than 0. This is the definition part of the logarithm. If they are equal to each other, gx must be equal to hx, and this is the solution. Here we have the question. If we explain on the question, now the bases are 1 over 5, logarithm base 1 over 5, and here 1 over 5. So this is 1 over 5, the first condition, which is fx. 1 over 5 is greater than 0, this condition, and 1 over 5 is not equal to 1. The first condition satisfied. Now we need to find the gx is equal to hx, then we need to check gx is greater than 0 and hx is greater than 0. Let's see. In this condition, it says that if two logarithmic equation is equal to arguments, this argument and this argument, they should be equal to each other. So this implies that x plus 2 over 10 is equal to 2 over x plus 1. If we crossly multiply, these are x plus 2 times x plus 1 is equal to 20 going to be. If we one by one multiply the terms here, x squared plus x plus 2x plus 1 is equal to 20. X squared plus 3x minus 19, because plus 2 it's going to be, this is per c, this is going to be plus 2, then this is going to be 18. Minus 18 is equal to 0. 2 times 1 is equal to 2, not 1. Okay? X squared plus 3x minus 18 is equal to 0. X are the factors, and minus 3 plus 6 the other factors it's going to be. So we are going to find x minus 3 times, we are going to take directly, we are going to multiply crossly, we are going to take directly. Okay, and it's going to be equal to x minus 3 times x plus 6 is equal to 0. Here you will find x1 is equal to 3, x2 is equal to minus 6. And after this step, we have to check. When you replace the 3 here by x plus with gx and hx, here x plus 2 over 10 and 2 over x plus 1, when you replace by gx, is it greater than 0? Here it's obvious that when you replace by 3, it's going to be greater. But when you replace by minus 6 cannot be solution here. Minus 6 cannot be solution, because minus 6 plus 2 over 10 is minus 4 over 10. This is smaller than 0. That's why here this condition didn't satisfy with this equation. We have to cancel the minus 6. Okay, now the new question. Here the conditions are same. We shouldn't forget these conditions. That's why I have pasted here. Logarithm base, the base is 10 here, you know that one, and the terms are logarithm base root x plus 21, x minus 22, and here 2 is equal to logarithm base 10, 2 is equal to 1. It's going to be, we are going to write like this: logarithm base x plus 21 plus root x logarithm base 10 logarithm root x minus 21 minus logarithm 2 is going to be equal to 1. Here the addition inside means, inside logarithm, inside the logarithm it's going to be multiplication. Root 21, x plus 21 x plus 21 times root x minus 21 over 2 is equal to 1. Here we know that the logarithmic base is 10, and that's why I'm going to write as the base of the exponential expression. Here this is going to come to this side, and it's going to be like this: root x plus 21 times x minus 21 is going to be equal to over 2, is equal to 10 to the power of 1 is going to be. Here we are going to convert to exponential form, and root of x squared minus a plus b times a minus b is equal to 21 square is equal to 20, it's going to be, and x squared minus 21 square is going to be equal to 20 square. It should be here 21 x squared minus 441 is going to be equal to 20 square is equal to 400, it's going to be, and if we write the equation here again, x squared is equal to 400 plus 441, it's going to be x squared is going to be equal to 841. X is equal to 800 root of plus minus root of 841, it's going to be x is equal to plus and minus 29 is going to be. When you replace the 29, it's not going to be a problem, because it's going to make this one and this one is positive. But when you replace by minus 29, here this is going to be negative. Let's say if you replace by minus root 29 plus 21, this is going to be negative. Exactly, it's going to be equal to minus root 8, which is not possible for us. So x is equal to 29, it's going to be minus part, we are going to cancel. This is new for us. This square term means, here it is written also, logarithm 3x per bracket square. So this is equal to logarithm base 3x times normal logarithm base 3x plus 2 times logarithm base 3x is equal to 3. And here this is going to be equal to, if it is equal to a, this is also a, and this is also a, then a square plus 2a is equal to 3 is going to be a square plus 2a is equal to minus 3 is equal to 0. A if you factorize, and minus 3 and plus 3 and minus 1 is going to be factors. Plus 3 and minus 1, they are going to be the factors. Then a plus 3 times a minus 1 is going to be equal to 0. So a1 is equal to minus 3, a2 is equal to minus 1. It's going to be, what does it mean? Plus 1, this is logarithm base 3x is equal to a, and here a is equal to minus 3. So logarithm base 3x is equal to minus 3, and logarithm base 3x is equal to plus 1. That's equal to, x is equal to minus 3 to the power of minus 3, and here it's going to be equal to x is equal to 3 to the power of 1. X is equal to 1 over 3 cube, which is equal to 1 over 27, or x is equal to 3. x1 is equal to, and x2 is equal to 3 is going to be. Okay, the next one, x logarithm 3x is equal to 3. How to solve this kind of questions? For this kind of questions, x logarithm base 3x is equal to 3. This kind of questions, you are going to send this one down, and it's going to be equal to logarithm base 3x is equal to logarithm x 3. The base here, it's going to be base of exponent, it's going to be the base of logarithm. When you see these two, if you remember, we solved this kind of question and we said like this: logarithm base AB is equal to 1 over logarithm BA. Logarithm BA. I need to change the bases, so I'm going to change this base. I'm going to make it this one positive, and pardon, this base 3, so it's going to be like this: logarithm base 3x, it's going to be equal to 1 over, when I say this expression, when it's written as 1 over form, logarithm base 3x it must be. Then if I say for this one it's equal to a, then this is going to be a is equal to 1 over a, and it's going to be like this: a squared is equal to, when you multiply, a squared is equal to 1, then this implies that a is equal to plus a is equal to 1, or a is equal to minus 1. Here if I write this one here, if I write, if a is equal to 1, it means that logarithm base 3x, I said it's equal to 1, so logarithm base 3x is equal to 1, that's equal to x is equal to 3 to the power of 1, or logarithm base 3x is equal to minus 1, x is equal to 3 to the power of minus 1, x is equal to 1 over 3 is going to be. Here if I rewrite this expression, logarithm base 12 minus 2 to the power of x is equal to 5 minus x, it's going to be, this is the C1, and logarithm base, here this 2, it's going to be as the base of the logarithmic expression, that's why it's going to be like this: 12 minus 2 to the power of x is equal to 2 to the power of 5 minus x, it's going to be. Here, and 12, not 11, sorry. Here it's going to be in this form: 12 minus 2 to the power of x, it's going to be equal to 2 to the power of 5 times 2 to the power of minus x, and 12 minus 2 to the power of x is equal to 2 to the power of 5, which is equal to 32. 32 times 1 over 2 to the power of x. Now if I send, this is division here in form of division, if I send to other side, it's going to be like multiplication: 2 to the power of x times 12 minus 2 to the power of x is going to be equal to 32. And 2 to the power of x here, if we write, instead of 2 to the power of x, if we write is equal to a, then it's going to be a times 12 minus a is equal to 32. Okay, then it's going to be equal to 12a minus a squared is equal to 32. If we collect the terms to one side, and if we make a positive, or minus a squared plus 12a minus 32 is equal to 0. To make operation with minus sign, it's going to be difficult for us, that's why I'm going to multiply by minus 1, and it's going to be equal to a squared minus 12a plus 32 is going to be equal to 0. If we factorize, this is going to be 16 times 2 normally, or 8 times 4. Yes, minus 8 and minus 4. If we say minus 8 times minus 4 is equal to 32, yes, it's going to be. Then a and a, it's going to be a minus here, a minus 8 times a plus a minus 4 is going to be equal to 0. Minus 8 times minus 4 is equal to plus 32, and the sum is equal to minus 12a. So a1 is going to be equal to 8, and a2 is equal to 4. So 2 to the power of x, it was equal to a here. So I'm going to replace by 2 to the power of x is equal to 8. X is equal to, as you know, it's equal to 3. 2 to the power of 3, this is because. And 2 to the power of x is equal to 4. 2 to the power of 2 is equal to 4. That's why x going to be equal to 2. When you replace the values here with 3 and with 2, 12 minus 4 or 12 minus 2, as you are going to understand, this is not going to be here negative. The 12 minus 8, 12 minus 4 is not going to be negative. So these both values are satisfying the condition. So they can be in the solution set. Okay.